Alright guys, so this is the video for section 12.6. There's going to be two videos, so this is the first one. And we're going to talk a lot about the distribution of probability experiments. So we're going to be drawing a lot of like histograms and things, which we've done before. So hopefully this video here, the first half, should be pretty much review for you guys. And it shouldn't be much new. The second half will be new, but it's just a formula that we're plugging stuff into and rolling with it. Alright. So, a couple vocab words, a random variable. Okay, a random variable is just a variable whose value is determined by the outcomes of a probability experiment. Probability experiment. Now, when I talk about a probability experiment, remember you could get different results from a probability experiment than you do from a theoretical probability, right? Usually these will differ in probabilities, especially if you have a smaller sample size. Now, the bigger the sample size is, the closer the probability experiment will be the same as the theoretical probability, but until you get to that extremely large number, usually they're a little bit different. All right, probability distribution is a function that gives the probability. I can't spell probability. Missed a T there. Of each possible outcome of a probability experiment. All right, so let's just look at a visual representation here. All right, so we did this probability distribution, and this is the theoretical probability, but we're doing the theoretical probability of rolling a six-sided die. Okay, so this is we roll a 1, we roll a 2, we roll a 3, we roll a 4, so on and so forth. And this is the probability that we roll a 1 is 1 out of 6. Probability that we roll a 2 is 1 out of 6. Okay, these won't always be the same as you'll see going forward, but in this case it is. And of course, this would be all of our outcomes, our possible outcomes, so this would all add to 1 or 100%, right? So you should always add those, and they should always equal 1. All right, so let's look at example 1a. It says, let x be a random variable that represents the sum when two six-sided dice are rolled. Make a table and draw a distribution or a histogram showing the probability distribution for x. All right, so the first thing I'm going to do, and some of you may not need to do this, but I do, I'm going to write out all the possible outcomes when I roll two six-sided dice. All right, so here is all the possible outcomes for rolling two six-sided dice. I could roll a 1-1, a 1-2, 1-3, so on and so forth, all the way to a 6-6. So if I count these up, there are 36 total outcomes. Okay, now I want to make a table to put all these outcomes in. Okay, so I'm going to let x be my sum. Now notice that the smallest sum would be a 1 plus a 1, which is a 2, right? And my biggest sum would be 6 plus 6 would be a 12. So I'm going to go 2 through 12. So there's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so here's the start of my chart. All right, now I want the number of outcomes here, and then the probability of that sum here. All right, so the sum of 2, there's only one way I can roll a 2, and that's if I roll a double 1. So there's only one outcome. Sum of 3, I have 1, 2. So there's 2 ways that I can roll a 3. There's 1, 2, 3 ways I can roll a 4. 1, 2, 3, 4 ways I can roll a 5. 1, 2, 3, 4, 5 ways I can roll a 6. 1 way, 2, 3, 4, 5, 6 ways I can roll a 7. 1, 2, 3, 4, 5 ways I can roll an 8. 1, 2, 3, 4 ways I can roll a 9. 1, 2, 3 ways I can roll a 10. 2 ways I can roll an 11. And the only way I could roll a 12 would be if I rolled that double 6. Okay, so my probability for each one of these, well, if I can only do it one way, that's 1 out of 36 tries. This would be 2 out of 36, 3 out of 36, 4 out of 36, 5 out of 36, 6 out of 36, 5 out of 36, 4 out of 36, 3 out of 36, 2 out of 36, and 1 out of 36. That's how many ways I can roll 2 die, and they sum to 2 through 12. Okay, now once again, if I were to add all these all up, they would add to 1 or 100% because this is every outcome is covered in this table. All right, so we've drawn a table. Okay, we've made a table. Now it asks us to draw a histogram. Okay, and we've done these before. So a histogram, here's the start of it. So my possibilities are 2 through 12. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. I made that a little longer than I needed to. All right, so my probability of rolling 2 dice that sum to 2 is just 1 out of 36, which is the same probability as rolling a 12. So I'm going to kind of, since this is symmetrical, I'm going to do them together. 3 out of 36 is double that. Or sorry, 2 out of 36 for 2, so we're doubling that. Probability of a 3 or an 11 is 2 out of 36. Okay, the probability of a 4, a little higher, 3 out of 36. Higher, 3 out of 36 for 10. 4 out of 36 to sum to 5. And also a 4 out of 36 to sum to 9. 5 out of 36 to sum to 6. And a 5 out of 36 to sum to 8. And hopefully your guys' looks a little better than mine. 6 out of 36 to sum to 7. So it looks something like this. This is perfectly symmetrical. It won't always be that way, but in this case it is. All right, so let's look at some questions that go over that histogram. So I've just drawn that histogram. I've just copied what I did here and plotted it right here so I don't have to go back and forth. All right, so on A it says, what is the most likely sum when rolling 2 6-sided dice? Well, the most likely sum, the biggest probability is right here, and the most likely sum is 7. Okay, and then part B says, what is the probability that the sum of the 2 dice is at least 10? Right, so this would be the probability of 10 or higher, so or 11 or 12. Okay, now remember, when this is an or, it's going to equal the probability of 10 plus probability of 11 plus the probability of 12, which is probability of 10 is 3 out of 36, plus probability of 11 is 2 out of 36, probability of 12 is 1 out of 36, which is what, 5, 6, so 6 out of 36, and if you wanted to reduce that, 1 out of 6 tries and rolling at least a 10 or a 10 or greater.